Okay, good morning all. So in last lecture we were discussing about LR circuit. Now in this lecture let us discuss about CR circuit, the growth and decay of current in a CR circuit. Now first, as usual, let us draw the circuit. Okay, first resistor in series, I connected a capacitor, battery of EMF E, and I connected this to a Morse key, 2 points A and B, right? Now, as usual, as what we did in a last circuit, what we will do? First, we will connect this circuit and C, which are in series, to the battery. Now, totally, now what happens? Current flows, right? The switch is thrown or key is thrown through point B. Now what is happening? Current flows in the circuit. So current flows in the circuit means capacitor is charging. Capacitor is charging. Means it is not sending the current in the circuit, but it is taking total current for its charging. So that is nothing but opposition created to the current, we can say, no? Whatever the voltage or EMF we supplied, it is taking that EMF for its charging. Now capacitor started charging. The value of capacitance of capacitor is, or the EMF. Now after charging, what happens? One plate will become positive, negative, it has charged. A EMF or a potential difference is created between the plates of capacitor. That potential difference will be equal to Q by C. A potential difference is created between the plates of capacitor. That potential difference is equal to Q by C. So now the total EMF in a CR circuit, it becomes, one is due to external source E minus, and it opposes the current, so minus Q by C. According to Ohm's law, it will be equal to Ri. Okay, after certain mathematical parts, the charging of the capacitor we get as Q equal to Q naught 1 minus e to the power of minus t by CR. Okay, t by CR. This is the value of charge at any instant t in a CR circuit. So as in LR circuit, current is growing exponentially. Here also in CR circuit, charge is growing or increasing exponentially. Now let us see the growth of charge. Time on x-axis, charge on y-axis. If this is the maximum charge, this will be the growth of charge. Let us define time constant. So time constant means time constant during growth. Now let us put t equal to CR seconds. What the equation does? Q naught 1 minus e to the power of minus CR by CR, that is equal to Q naught 1 minus e to the power of minus 1, Q naught 1 minus 1 by E, Q naught E minus 1 by E, Q naught 2.718 minus 1 by 2.718, and answer comes out to be the 0.63 Q naught. So what is the times D constant? Time constant at t equal to CR seconds, if the charge or the charging increases to 63% of its maximum charge, then we call it as time constant of CR circuit. Now as usual, let us see the behavior of capacitor during growth. Behavior of capacitor during growth of current or growth of charge. As usual, we connected to the battery. The charge is increasing. Okay. Now it also offers resistance. It is storing the charge, It is not sending into the circuit. But starting initially, it is storing the charge. Initially, it is storing the charge means nothing but it is creating a resistance to the flow of current. Resistance to flow of current. Right? Now, the charge which has already been built up on the plates opposes any further charge moving towards it. Okay? So, but here already the charge which is built on plates opposes any further charge to move towards it. It will not allow the further charge to come here. So due to the resistance offered by the capacitor, as usual there will be potential drop. You understood? Already it has charged. Now it opposes the further charge to come. It opposes the further charge to come because already it is charged. This built charge on the capacitor plates opposes the further charge to come. That is nothing but it is creating resistance to the current. Now due to that resistance, as usual, a potential drop will takes place. Now this potential drop increases, okay, with time because resistance increases with time. Resistance is increasing means potential drop is increasing. Okay, so resistance is increasing means potential drop is increasing. As usual, a steady state will be reached. At that steady state, this resistance to flow of current becomes infinity. Now no current flows through capacitor. In such a way, capacitor blocks the flow of current. How capacitor blocks the flow of current? How the capacitor blocks the flow of current means, at steady state the resistance is becoming infinity, means it is becoming more and more. Infinity means it never allow any current to flow through it. In such a way, capacitor is blocking the current. Okay. Now let us go for the decay. Decay of current or charge, through capacitor. Okay. Through capacitor. Alright. So as usual, we disconnect from point P and connect to A. Means we disconnected the battery. Now capacitor starts when now Morse key is thrown to point A. So capacitor starts discharging. So total EMF becomes E becomes 0 now. It was E minus Q by C equal to Ri, no? Now it has disconnected, so minus Q by C equal to Ri. After certain calculations, we get the decay of charge expression as Q is equal to Q naught e to the power of minus T by CR. Now discharge formula. Substitute T equal to CR. You will get time constant as Q equal to 0.37 I naught. The time T equal to CR seconds taken by the capacitor to discharge to 37% of maximum charge Q naught. to decay to 37% of maximum charge Q naught, we call it as time constant. And if we draw the graph, from maximum charge it is decaying to 37% of maximum charge. Time charge. Right? Now let us move for LCR circuit. Inductor, capacitor, resistor. LCR circuit. Okay. So now here in LCR circuit, what happens? Let us see. First let us draw the circuit. Okay. How will be the circuit? Circuit will be capacitor, resistor, inductor, are connected in the series. Morse key or switch, you think. Point A, point B. External source of EMF E. Right? Inductor, capacitor. Now total EMF. In our last video and this video we are just going on explaining, no, E minus, due to capacitor a potential drop, minus Q by C, due to inductor back EMF minus L di by dt according to Ohm's law equal to Ra. E minus Q by C minus L di by dt is equal to Ra. After doing some calculations, we get the growth of charge in capacitor. Q equal to Q naught minus Q naught by 2 1 plus K by under root K square minus omega square e to the power of minus K plus under root K square minus omega square into T minus Q naught by 2 1 minus K by under root K square minus omega square e to the power of minus K minus under root K square minus omega square T. So this mathematical derivation you did in classrooms. Okay. Once check your notes for this mathematical derivation. Now here 3 important cases takes place. Now I am drawing a graph. By taking time on x-axis, charge on y-axis. Let this be the maximum charge. The graph we will get 3 situations. In such a way. Situation 1, situation 2, situation 3. First let us discuss about case 1. Okay. Let us discuss about case 1. So here in case 1, K square will be greater than omega square in this formula. When K square is greater than omega square, what happens means R square by 4 L square will be greater than 1 by LC. Right? Okay. So now here what happens means both terms are exponential. The exponential terms are real. These both exponential terms are real. So charge increases exponentially. Charge increases exponentially as in CR circuit. So without crossing this If we take it as mean position, immediately the charge stops. Okay, this is the first situation. In second situation, k square equal to omega square. This we call it as first one, over damping or large damping. Do you know what is damping? Damping is nothing but reduction in amplitude. Reduction in amplitude of current. So without doing oscillations only, the current stops in the circuit if damping is more. The amplitude decreases. Do you know the example of simple pendulum? What happens once if you start oscillating the simple pendulum, it oscillates slowly, its oscillations reduce and come to the rest position. No? Oscillations are reducing means nothing but reduction in amplitude takes place. Oscillations are reducing means nothing but reduction in amplitude takes place, and at last amplitude becomes zero and oscillation stops. But here, due to over damping, without performing any oscillations, the charge stops flowing in the circuit. Second situation, we call it as critical damping. Right? Second situation, we call it as critical damping. So in such a situation, the charge rises to maximum value. Charge rises to maximum value in short time itself only, and without performing any oscillations, the charge stops. Rises to maximum value in short time, and without performing any oscillations, it stops. Now the third situation we call it as k square less than omega square. Right? So here under root k square minus omega square becomes imaginary. After certain calculations, we get the formula of charging as Q equal to Q naught 1 minus k e to the power of minus kt by under root omega square minus k square sine under root omega square minus k square into t plus alpha. Now you see the expression. Sine term is involved in the final expression. How will be the sine form? The sine wave form, it will be in such a way. Sinusoidal wave. Right? Means from mean position we can say no, this waveform is in such a way. Once towards positive direction, other towards negative side. Means from mean position it is vibrating we can say, or it is oscillating we can say. Okay, so this is the third situation. Here as a sine term is involved in our final equation, it indicates that the charge oscillates. Charge oscillates, and this we call it as small damping. Means here damping is very less, means resistance or opposition to the current is very less. When k square becomes less than omega square, the opposition created to the current is very less. So only the charge oscillates. Charge is oscillating means charge is exhibiting simple harmonic motion. The charge is oscillating means nothing but charge is executing simple harmonic motion. Right? The charge is exhibiting simple harmonic motion. And now let us find out the frequency. Right? So the frequency value, here k we call it as damping, omega angular frequency, k square less means damping is less. K square is more means damping is more. K square equal to omega square means damping is nearly equivalent to natural frequency. Okay, or sorry, angular frequency. Okay, now similarly Let us find the value for the, what we will say, frequency. First, time period. Time period means we will write 2 pi by beta. So you will get the complete mathematical part in the textbooks. Just for your entrance point of view, I am saying omega square minus k square, right? That is equal to 2 pi by under root. Actually omega square we will get 1 by LC. Now 2k will be equal to r by 2l. That is k equal to, sorry, r by l, 2l. So k square becomes r square by 4 l square. So 1 by LC minus r square by 4 l square, time period. Similarly, frequency means this is time period. Okay. So 1 by t, 1 by 2 pi under root 1 by LC minus r square by 4 l square. Alright. Similarly, we can also go for decay of charge. Okay, we can also go for decay of charge. Right. In decay of charge also, the similar cases we will find. So let us see whether decay of charge is oscillatory or not. Yes, the decay of charge is also oscillatory. Case 1, k square greater than omega square, over or large damping. Over or large damping. So it will not do any oscillation. So it is non-oscillatory charge is flowing. Non-oscillatory charge is flowing through the circuit. So such oscillations we call it as deadbeat oscillations of charge. Now case 2. What is case 2? K square damping is nearly equivalent to angular frequency. So here charge decreases in a short interval of time. Here also it will not perform any oscillations and stops. Now case 3. So here damping is less than angular frequency. So damping is less means in final equation we will get Q equal to some Q naught dash e to the power of minus kt sine beta t plus alpha. Means sine term is involved means nothing but it will perform oscillations. Okay, as damping is present, low damping is present, at last the charge comes to the rest by performing oscillations. Performing oscillations means charge is exhibiting simple harmonic motion. Charge is exhibiting simple harmonic motion. Charge is exhibiting simple harmonic motion. Alright. So this is about LR, CR, LCR which I dealt in my 2 videos. So stay with my channel Reshma Physics. If you like this video, just share it, subscribe it. And in our next video, let us see about the alternating currents, sharpness of resonance and quality factor. Thank you.